without going into much detail as to how we find A inverse, we'll allow our calculator to do that for us. So what we're going to do is we're going to enter the matrix A, we're going to take it to the inverse, and we're going to multiply that result by B. So we're just going to do it all at once, so that we get our answer, which is capital X equals -5, 5.5. Well, what does that mean? Well, the X matrix, remember, that's just an abbreviation for this guy here. We equated that to that, so that means that the matrix containing X and Y is equal to -5, 5.5. So that means that the solution is X is -5, Y is 5.5. That's exactly where these two lines are going to intersect. If we quick went over to www.wolframalpha and we entered these equations in, we did X plus 2Y equals 6 and 3X plus 4Y equals 7, we should get the same solution. Let's just double check on that really quick. There it is. X is -5, Y is 11 over 2, which is the same thing as 5.5. Okay, let's do a problem now. So this problem, and I apologize it doesn't show up very well, let me try this again. In this problem, we're told big stadiums such as the University of Phoenix Stadium in Glendale bring in many sports fans each year. Suppose that a smaller stadium is working on pricing its tickets for a football game. There are 3 seating zones, low, middle, and high, the nosebleed section. The high zone tickets will cost 60% more than the low ticket zone tickets. There are approximately 20,000 low zone seats, 15,000 middle zone seats, and 10,000 high zone seats. A total revenue of $2.25 million is desired, assuming all seats sell out. The medium zone seats will be priced halfway in between the low and high zone seating prices. What should they charge for each ticket? So we're going to let our variables, since the question is what should they charge for each ticket, we'll let L equal price for low, we'll let M equal price for middle, and we'll let H equal price for high. Okay, so we know first of all the high zone tickets will cost 60% more than the low zone tickets. So to get the high zone price, we're going to take the low zone price and we're going to multiply it by 1.6. I guess I should probably use a capital L here. So 1.6 times L should give me a price 60% higher for the high tickets. There are approximately 20,000 low zone seats, 15,000 middle zone seats, and 10,000 high zone seats. A total revenue of $2.25 million is desired. Okay, well, how are we going to get $2.25 million? First of all, I'm going to write that out in longhand form so we get everything in actual dollar amounts. Well, the price for the low zone seat times the number of seats, which is 20,000. So L dollars for 20,000 seats plus H dollars, M dollars, excuse me, for the next 15,000 seats plus the high zone seat price times 10,000 seats at that price will give us $2,250,000. And then finally, the medium zone seats will be priced, so medium will be priced halfway between the low and high zone seating prices. So how do we get halfway in between? Well, we can take the difference and we can divide that by 2 and add it to the low ticket price, or we can just take the average, because that's really what we mean. So if we take the low plus the high and we divide that by 2, that'll give us a place halfway in between. Or we could write 1/2 L plus 1/2 H will give us the number of the price for the medium seats. Okay, so next what we'll do is we'll write out all of our equations so that we have low, medium, and high variables. So this guy, I could rewrite this to read H minus 1.6 L equals 0. So that means negative 1.6 L plus, well, how many M's do I have in this equation? I don't have any, so I'll write 0M plus minus 1.6 L. I've already done L. H, so plus H, and I want that to equal